Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay. Happy Friday. Today is July the 12th, 2024. My topic of discussion is under physics. We're going to discuss lesson number 16 and we're going to find out what a instantaneous velocity is. Okay? So this is a great physics lesson because we've been talking about physics, we've been talking about displacement, we've been talking about vectors, we've been talking about velocity, but today the topic of discussion is instantaneous velocity. But before I dive into it, I would just like to see if I can tell you a real story about myself, which is kind of like a joke also. So back in 1986 summer, I was going to University of South Alabama in Mobile, Alabama, and there was a church associated with our school, and basically they needed somebody to sell encyclopedias and Bibles. So I volunteered for that, and obviously there was some monetary benefit also for that. So what they did was that they put us in a hotel right on the border of Georgia and Alabama. I honestly don't even remember the name of the town, but it was somewhere around border of Georgia and Alabama. And our task was to basically go out into different neighborhoods and just knock on the door and tell them, "Hey, my name is this." We had a badge and everything. That my name is Nas, and can I please talk to the family member or father or mother? And then I would go over and I would tell them, we have this Bible and we have this encyclopedia. As of today, you have information on your palm. All you got to do is just Google or go to Wikipedia and find out what the answer is, whatever you're looking for. Highest mountain in the world, okay? The finest lake in the world, the biggest continent. Everything you can Google it and boom, instantly you get an answer. But in those days, you needed an encyclopedia. So, anyways, I still remember the cost of Bible and encyclopedia was like, I think it was like $18 per piece. And we were getting a little bit of commission and so forth. So, the funny thing, what happened was that, and that's the punchline of my joke, is that anytime when I would go to a black neighborhood and I would knock on the door, and there would be a child outside, a little boy on a bicycle, and he would say, "Who are you?" And I would say, "Can I talk to your mom and dad?" He would say, "Okay," and then he would run into the door and say, "Mama, mama, mama, there is a white man outside." I'm like, okay. And then on the contrary, when I go to a white neighborhood, and I'm selling my Bibles and I'm selling my encyclopedia, knock on the door, and there would be a little white kid playing outside, and I would say, "Can I talk to your dad or mom, whoever is at home?" And they would just run inside and say, "Hey, mama, 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 there's a black man outside." So I thought that was kind of funny. And I wanted to kind of share that with you. But, anyways, let's go ahead and get back and dive into instantaneous velocity. So, what is instantaneous velocity? Okay, you have point A, you have point B, and you're driving a car from point A to point B, all right? So, the average velocity is the distance and the time it takes you from point A to point B, and the time it takes you. So what we do is that we divide the distance by time or meter per second. That's your average velocity. But what about the velocity at a specific instant, right? That's what I'm looking for. I'm driving 10 miles per hour, and then all of a sudden I'm driving 20 miles per hour. Okay. So, what is my velocity at this particular instant? That is instantaneous velocity. And that is what we are going to learn today, how to find out what instantaneous velocity is. But let me go ahead and review, or recall, let's say, recall what is average velocity. Okay. So we're going to recall average velocity. I just gave you a little scenario. Okay. So average velocity is, I'm going to say V average is equal to, let's say you have 2 points, A and B. Okay. This is my initial point, so I said xi. This is my final point, so I call it xf. Okay. And then the time it takes from initial point is ti and final is tf. Okay. So then my V average is going to be xf minus xi over tf minus ti. Now we can say change in x divided by change in time. And in mathematics, a change is represented by delta. So I can call this delta x over delta t. By the way, delta is a Greek word which basically means change. Okay. So then we can say V average is equal to delta x over delta t. So that's my average velocity. All right. So this is basically a recap, and I showed you that also in my last lecture. So let's say another thing is that let's see, how do you find average velocity? Let's say you have x-axis, okay, and then you have y-axis, okay. Sorry, this is x-axis and this is y-axis. So let's say this is x distance in meters, and let's say this is time in seconds, okay. So let me go ahead and draw some lines over here, tick marks over 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. All right. And let me go ahead and draw a line, straight line right here, just like this. Okay. So, in other words, what I'm saying is that let's say at 3 seconds, this is 1, 2, 3 seconds, this is the distance I've covered. How much distance I've covered? I've covered approximately 2 meters. This is 2. Okay. So then I go to the 4, and then I go to the 5, and I go to the 6. At 6 seconds, my distance covered is 1, 2, 3, 4, 5. So this right here is my distance covered right here. Okay. So I would like to see if you can find average velocity based on the graph I just showed you. So the change in time is from right here. Okay. And change in time right here, and then change in distance is right here. Okay. So this delta x is 2, as you can see right here, 2. And then delta t, as you can see right here, 1, 2, 3. And 6 minus 3 is 3, is 3 seconds. Okay. So delta x is 2 meters. So then my average velocity, V average, would be equal to delta x over delta t, which is equal to 2 meters divided by 3 meters per second. And you can convert that into decimal form, refine it, but this is the answer. All right. I'm going to come back and we're going to talk more. All right. Sorry, my joke took a little bit of time, but it was really funny. So I wanted to share that with you. But hope you liked so far. If you like the contents, please go ahead and give me a like and also share. Sharing is caring. Thank you.